Hi everyone. Today I will be doing a small demo on a cool new custom application. I am for the timing calling it as a JQL generator. JQL is basically an acronym for JIRA Query Language. JQL is used for extracting data from JIRA. Our new application basically converts natural language, which comes as an user input, and then converts it into JQL. And then we use the JQL to fetch data from JIRA. So first thing is, before diving into this application, I would like to share some of the problems that we are currently facing. So JIRA users often struggle with constructing JQL queries to filter tickets efficiently. So people who have been using JIRA, you cannot expect them to know coding. They may or may not have a coding background. So at times they struggle with data that is required to be fetched from JIRA. Users must remember the exact field names to come up with the right syntax. That's another challenge. Then the third thing is we have a lot of foundational models, LLMs available in the market. We can simply query and get the information in the form of JQL, right? We can talk to ChatGPT, explain them what we need, and they can provide us the JQL. But the problem is the foundation models which have been existing, they often don't understand the org specific jargons, the custom fields which we have in our organization, because they are not trained on those custom data. That's why we need something like JQL generator, which can help us convert natural language into JQL. And then the JQL generator can act as a JIRA agent and pull the data from JIRA and show it in the form of a report. So without wasting any time, what I will basically do is I will go through some of the user queries. We'll start from simpler ones and then we'll move to the complex one, and we'll see like how the JQL generator is reacting to these queries. So, okay, I have already opened multiple tabs and I have put the JQLs in the interest of time. So the first one says shows all the issues assigned to Devi Mahapatra. So I have a free version of JIRA available with me. It has very limited features. So I have few tickets created on my name. So let's see how this behaves. So first thing is the application should be able to understand the natural language and then convert it into a JQL. So let's see what's the JQL. Okay, so this is a pretty simple one. We want all the tickets that are assigned to Devi Mahapatra. So now I will submit this JQL to JIRA. And this is the tabular report which I am fetching. So I have a bug and a story, and these are some information associated with those tickets. Then we'll move to the second one, that is slightly complex query. Still, I would say like this is simple, but in comparison to the previous one, it is slightly complex. So all the issues assigned to Devi Mahapatra for project My Scrum team, My Scrum project. So what it basically does is it queries on the assignee equal to Devi Mahapatra and filters on the project that I have requested over here. So this is the tabular report which I have fetched. Now we will see, we'll make some more changes. Extract all the bugs and tasks created within last 7 days. Let's see how the generator behaves here. So these are the bugs that has been created in last few days. Okay. This is a pretty complex query. I mean, the length of the user query is also slightly bigger in comparison to the previous one. Here I'm trying to extract all the issues of type feature assigned to John Doe and created in last 60 days and have a priority marked as high or critical. These issues should belong to team gladiators and should be part of the agile release train that we have named it Avengers. Additionally, the roll-up story points must be greater than 100. Exclude any issues that have been updated in the last 7 days. So it's a pretty complex requirement. And our generator was able to fetch the JQL based on the requirement that we have placed over here. And it looks correct. I won't be hitting it into the JIRA because my database, I'm sorry, my JIRA is not having a lot of information and it would fail. But the JQL, if you see, it's totally correct. We will go ahead and create another complex query. And here I am trying to extract all the issues of type bug and tasks that were reported by Alice and in the last 90 days, but they are currently assigned to Bob and Davis. The issues must belong to a project named as Phoenix and should be part of agile release train named as Omega. Additionally, they should have a priority of highest or high and should contain a label production and should have at least 5 story points. We need to exclude all the issues that were resolved in the last 30 days, and we have to sort it in a descending order. So let's have a quick look at the generated JQL. Issue type is bug or task. Reporter is this, and it was created within last 90 days. And the assignee is Bob and Davis. Project is Phoenix. Category is, that is art, is actually a category as per the org jargon that we have used. Priority is highest and high, and the label is production, and the story points is greater than 5, and it was resolved within the last 30 days, and we have ordered it by the date in descending order. So this looks cool, and I feel like the JQLs are coming up correctly. Now let's have a quick look at the solution architecture of this JQL generator. So there are two sections, one where we are creating a vector store, and the other section on the right from here, the one that is within a dotted box, is the prompt augmentation and the response part. So as a part of creating a vector store, we have created a CSV file which is specific to the org that I am considering for this pet project. I have some custom values and jargons that I have used. So here I am taking the CSV file as an input, and I am using an embedding model, Amazon Bedrock, through Amazon Bedrock, and the model name is Amazon Titan Embedded Text V1. I am doing the embedding on a particular column, and then the data gets stored in a vector DB. It's a Postgres database. So once the knowledge base is created, what we do is we will go into the other section where the user requests, and we will see like how the user is interacting with our generator through multiple LLMs. So first, the user is sending its query, and what we basically do is we are converting that query into some keywords based on the context that is related to JIRA. Then these keywords are generated in the form of a list. So each keyword value goes into the vector database. We do a matching So before matching, we actually embed these keywords also. And based on a similarity score, we get the context from this database. So what happens at the end is when the user sends a user query, the data goes into the vector database and it gets additional context. And that way our prompt becomes richer and has more information. It also considers the org specific jargons and business terminologies and creates a strong prompt. Then this prompt goes to our foundational model. In this case, we are using Claude 3.7 Sonnet, and we ultimately get a final response. And this final response is then directed towards JIRA to get the data. So yeah, that's all from my side. Thank you, everyone. Please let me know your inputs. Thank you very much.